It's been quite a while. I hope you're doing well. Anyway, I saw this problem in social media and I think it's a good problem for those who have not yet met this type of problem or are not familiar yet on how to solve this type of problem. So we're given here that x squared is equal to x plus 1 and we're looking for the value of this expression here. So it's basically a sum of several powers of x and 1 over x. So basically, if you look at each term here, we note that it can be written in the form a squared plus b squared. Where in this case, for the first one, that's a being equal to x to the fourth, while b being equal to 1 over x to the fourth, because x to the fourth squared is x to the eighth, and 1 over x to the fourth squared is 1 over x to the eighth. So this is the property we'll try to exploit, and that should apply to the three of them. For the first one, it's 8th power, second one is 4th power, and the third one is the third power. The second power. So let's do this. So let's start with what's given to us. So we're given that x squared is equal to we're given that x squared is equal to x plus 1. We can put the 1 on the left side so that we'll get x squared minus 1 is equal to x. And then divide both sides by x. This gives us x squared minus 1 over x is equal to 1. And then the left side, we can split the fraction as x squared over x minus 1 over x. The right side is 1. Then we simplified x squared over x as x. So this gives us the equation being equivalent to x minus 1 over x is equal to 1. Now this is quite, in a way, similar to the expressions that we're looking for, except that the sign here is a minus instead of a plus. Now we can do something about it by squaring both sides. If we square both sides, the left side will be x minus 1 over x quantity squared. The right side would be 1 squared, which is simply 1. Now the left side is a square of a binomial. And recall that the square of a minus b is equal to a squared minus 2ab plus b squared. But in this case, a becomes x, b becomes 1 over x. So the left side here, using this square of a binomial formula, becomes x squared minus 2 times x times 1 over x plus the square of 1 over x, which is 1 over x squared, and then the right side is 1. Note that we can cancel out the x here, so the middle term is just negative 2. So we have here x squared minus 2 plus 1 over x squared is equal to 1. And if we put the 2 on the right side, essentially adding 2 to the both sides, we get x squared plus 1 over x squared is equal to 1 plus 2, or 3. Therefore, this last term here is equal to 3. So we have here x squared plus 1 over x squared is equal to 3. Now we can do again the same process. We square both sides. And when we do that, note that we'll get something like x to the fourth on the left side. So we get here x to the fourth plus 2 times x squared times 1 over x squared plus 1 over x to the fourth is equal to 9. Again, the middle term simplifies to just 2. So the left side here is equal to x to the fourth plus 2 plus 1 over x to the fourth is equal to 9. We put the 2 on the right side, we get x to the fourth plus 1 over x to the fourth is equal to 9 minus 2, or 7. Therefore, this part here is equal to 7. So we only need 1 and that's the 8th power. We can do that by squaring this again. I'll just do the shortcut here. That will be 7 squared minus 2, and that's equal to 47. So the first part here is 47. Therefore, the answer we're looking for here is 47 minus 7 minus 3 is equal to 37. Therefore, the answer here is 37, and that's our final answer. So this is quite a nice trick to answer this type of problem. Of course, an alternative way here is for you to solve for the value of x and plug it in here, but it's not going to help you much because, well, you're looking for the 8th power, and that's quite a lot of evaluations if you find the exact value. So I suggest that if you are a mathlete interested in joining math competitions, that you try to master this technique, because this is a staple in both local and international math competitions. Okay, that will be it for this video. Thank you for watching, and see you on the next one. Bye-bye.